But what we're going to get into here with this nuts and bolts of IO-Link discussion is essentially a response to a webinar that we did last year. We did a webinar that went through kind of the benefits of IO-Link and what is some of the information that you can get and why should you choose IO-Link. Coming out of that, we got a lot of questions about, yeah, I understand why I should do it, but what's the data actually look like? What am I going to see? And so what we're going to see today is an actual look at what's that data look like in RSLogix. Now, we're not going to get through in a 30-minute webinar exactly getting everybody up to speed and integrating a full sensor. But what I want to show is some of the support resources that we have available. We've got some videos on YouTube. We've got a lot of expertise in our application engineering team. We can help you through those steps. And so I'll just kind of show an example of going through that. I'm going to start with a couple of slides that kind of ground us on IO-Link, just that we're all on the same page. So this is a slide that I showed in the previous webinar. What is IO-Link? It's point-to-point. It's not SIG specific. There's a consortium that puts this together. It's kind of serial-based, uses 3 wires. And then one other kind of common question that we'll get there is our typical cycle time, being 2.3 milliseconds on IO-Link. And if we haven't done it, the poll question can go out. All right, another slide that we did in the last presentation was major benefits of IO-Link. And this is something that the IO-Link consortium, it's over 200 companies, came together and said, this is really what you're going to get out of IO-Link. You're going to get simplified installation. We don't have to terminate cables anymore. We can just run M12 connections into blocks and get that on Ethernet. So we're not stripping wires anymore. You're going to have automated parameter settings. If you have changeovers where operators are going through and pushing buttons on sensors, you can get rid of that. IO-Link masters and PLCs can hold those parameters and send them down to the individual sensor. And then there's also expanded diagnostics. So this is kind of that root cause. This is where we can get into a lot more information. Me as SIC, as a sensor person, I'm not going to be able to tell you, the machine manufacturer or a user of a machine, exactly what you need. We kind of have to work together to figure out what extra parameters really matter in your application. But there's a world of possibilities that we can get to down to that level. Now, if you look at these 3 benefits of IO-Link and you say, yep, I'm ready to go, I've got it. I'm going to use IO-Link. Great, we can help you do that. But in most cases, it's got to take that conversation between the sensor people and the machine people. Hey, it might be interesting if I get temperature. Can you give me temperature? Well, let me see. Okay, we got 10 sensors over here that can give temperature. Let's see if they can maybe take the place of something already doing detection in your machine, but also give you temperature. So it's just kind of a look at the next layer that we can get into the sensors. One other way I kind of like to explain IO-Link is if you've ever had the thought, hey, I wish there was an Ethernet version of that sensor. I use an inductive here because it is, of course, the lowest cost, seemingly dumb type sensor. But now with IO-Link, we can spread that cost of going to a field bus, going to Ethernet, Profinet, EtherCAT. We can spread that cost across multiple sensors. You have an IO-Link master, something like this. I'll show in a couple of slides as well. You have multiple ports on there. So now we could take the cost of going to Ethernet connections, upstream and downstream, and we could spread that across 8 sensors, 4 sensors, whatever it is, so that we can keep that barrier to entry low and get extra data out of a sensor. Temperature is one that I like to use a lot. Voltage warnings, if you have some power spikes in your machine, you could start to monitor that in the sensor. All right. Again, what we're used to today is we've got an IO-Link sensor, or a standard digital I/O sensor. That's really just the tip of the iceberg. That's yes, no, it's what we see in the middle of this page here. I'll kind of cover it here. It's a 1 or a 0, yes or no. That's all you get out of a sensor today. But under the surface, there's all kinds of extra data that sensor can provide. Today, I'm showing you kind of a look at a clear material sensor that's looking at a reflector. As that sensor sees dust build up on that reflector, the light level, that's this black line right here, starts to trend downwards. It'll trend down over time, and actually most sensors today, they have a threshold that can automatically adjust. That threshold is the blue and the green line there. They'll adjust down as well. If you don't know what's going on in your machine, that threshold could be changing like crazy, and you might be having an operator that's always cleaning the reflector. They don't necessarily have to clean the reflector. They could spend their time elsewhere in the machine. They don't have to always be cleaning it. This will give you a real life feedback on, hey, how much extra gain do I have? How often do I have to clean the reflector? Maybe I can schedule that at planned downtime rather than letting a sensor cause some unplanned downtime. Okay, I mentioned briefly the iLink masters, but again, this is the way that we spread out the cost of going to a field bus. So you've got, we've got an IOLG master, it's got 8 ports on it, and you could plug in 8 sensors and take it to Ethernet, IP, EtherCAT, or Profinet. And then we've got the iLink slave modules as well. Those are a low-cost module that is essentially a field digital I/O card. So it's IP67, you can mount it out in the field, and then you're connecting with M12 connectors rather than stripping wires and taking them into the panel, into the PLC. So iLink master and slave. Today I'm going to show you the steps to integrate one sensor into the iLink master module. Okay, I said a little bit earlier too, we got to kind of work together to figure out where are the real benefits of IOLink. We could throw stuff at the wall. We could show you a whole world of possibilities. This is a dashboard that isn't a SICK specific dashboard or a software program. We can run this on Amazon Web Services if we want to. But we can throw this dashboard, we can link sensors to the dashboard, and then you can monitor that information, look at the history. Really, if you want to start doing root cause analysis and process improvements, you got to first have the data, you got to have the history, and these dashboards are what are going to help you see that history. This one is just an example. It's an inductive sensor, an IMC, and then an FPS is a flow sensor that can also track temperature. So it's just a quick look at what could be done, but we really want to work together and figure out what parameters are important to you. All right. So now we'll really get into it. This is, again, we want to get down to the nuts and bolts. I want to show you bits and bytes and ones and zeros and show you how to make those mean something. What I'm going to do here is I'm going to walk through essentially what we have available in videos. So this is just a look. YouTube, if you search SICK IOLink, I'm going to walk through these 3 videos, the ones with the words on them. SICK IOLink Master Integration, SICK IOLink Master Integration 2, 3, and 4. There's actually 4 videos that go through step by step every single step, every single byte bit that we change to get an add-on instruction implemented into your PLC so that you can see data on a sensor that makes sense. Not random ones and zeros, it's a threshold level that you're used to seeing. So that's what I'm walking through here. Feel free to go ahead and search out those videos. It's probably about an hour and a half worth of content going through all those, but you can watch it at your own speed, speed it up, slow it down, and make sure that we get all the steps going through. But again, I'm going to walk through just one example and show you where we could see all this information. So what we're looking at here is, I'll show pictures on the right, and then normally we'll get to the RS Logic screen on the left here, but what we're looking at is one master. We've got a sensor plugged into this 3rd port down here. It could be port 3 in your mind. Actually, our ports start numbering at 0, so it goes 0, 1, and 2. This is port 2. And the sensor that we're looking at is a KTS contrast sensor. That one's interesting because it can give you a color value. It doesn't just give you a yes or a no like a photo eye would. This one will give you, hey, I see something, yes, no, but also it's a number between 0 and 999. So it's kind of a little bit more interesting than just a basic photo eye, and that's why we used it. So what we're looking at here is we've got port 3 or port 2. If you start numbering at 0, port 2, we're looking at IOLink data that would be coming in to our RS Logic PLC or Rockwell PLC and the RS Logic software. Port 2, if we're looking at our documentation, we can see that the IOLink master gives us many, many bytes of data coming in from a sensor into that PLC. Port 2 starts at byte 104 and available all the way up to 151. We got 47 bytes that we could use, but I happen to know that our KTS only really uses 2 bytes of process data. So we're going to go ahead and look into the PLC. Let's look at bytes 104 and 105. So here, a little bit fuzzy video, but there's nothing too important here. You'll see that if we go into our controller tags in RS Logic, I'm skipping the integration of an IOLink master because all we're doing there is loading an EDS file and getting our IP address set up correctly. So we'll skip that step. You don't have to, we don't have to spend time on this, but I do have a video showing it on IOLink if you search for it on YouTube. But you'll see we've loaded the master. I give it a name. Anything I've ever touched will say that I'm awesome. And then we're looking at bytes 104 and 105. So this is our actual KTS process data. It's live process data. You can see right now we've got a value of 100 and minus 48. Doesn't really mean anything to us right now. There's no minus values that you're going to get out of a KTS sensor. So let's dig into it further and figure out why those values look a little bit funny. Here we can expand the actual bytes that we're looking at. So this is 104 expanded to see the individual ones and zeros. This is where we start to get close to what we're looking for here. Ones and zeros, what do those ones and zeros mean? Now this is where we take a step back and we look at our sensors, the sensor you have connected, and let's look at its process data, the information that it's putting out to this IOLink master, to the PLC. So every 6 sensor that has IOLink is going to have something like this. It's an IOLink data map. The top will talk about how IOLink works, but then number 2 here is our process data, and number 3 is our service data. This is the map. This is all those indexes. What do they actually mean? And so as we start to use these, they're actually pretty easy to use, but if you haven't seen one before, it can be confusing. So I'll step through that right now. The process data, this is an expanded view of our process data. We've got byte 0 and byte 1. This is the KTS puts out 2 bytes of process data. We're looking at byte 104 and 105 in RS Logics. That's what we're looking at right here, okay? So 104 and 105. I think if we build here, we'll see 104. This is just to show that the data does change and that it's live, but you'll see on the left here, we've got one setup where the KTS is looking at a white background, and we get our decimal values of 100 and minus 48 and all these ones and zeros are sequenced there. If we put a black background underneath it, now we've got decimal values of 31 and 81 and a bunch of ones and zeros underneath each of those. Let's look back at that data map and understand what those ones and zeros mean, okay? If I'm going too fast, I do urge you, find those YouTube videos. You can slow down on YouTube. I'll go back and reference if I have a step that I don't quite remember. I'll go back, pause, play. It walks you through every single one of these steps and explains what I'm going through here too. All right, so here's that data map. Took a screenshot from RS Logics. We've got our 100 and minus 48. And now we'll put the KTS process data on the same screen. What are we looking at? What's going on? I've got a bunch of ones and zeros. Most of us use the calculator on the PLC or on your PC, and we'll enter a binary value, and then we'll convert it to decimal. So ones and zeros, where do I start? What do I start entering into that calculator on my PC? What we're looking at here is our measurement value emission color. We're going to start at bit 7 on the first byte. So that's bit 7 on the first byte will be right here. We've got a 0, and this is what we're entering into the calculator as well. So we'll go 0, 1, 1. The leading 0 isn't shown, but then you'll see we have a 1 and a 1. And then we go 0, 0, 1, 0, 0. And then don't forget these last 2 right at the bottom here. This is part of our measurement value emission color. Maybe skimmed over that, but our measurement value for emission color is this entire byte and then part of the next byte. If stitching that information together is easy for you, you can probably drop off the call right now. You're going to be able to get that information, but I'll show you how add-on instructions can make it easier as well. But then once we finish off, we've got our 1, 1 at the very end. If we convert that to our binary value, or decimal, sorry, from binary to decimal, then we'll see a value of 403. And back on the sensor, this is what actually means something to us. Value between 0 and 999 is 403. That means we're looking at a white target. 400 is actually what we calibrate for white. So it's very, very close to a standard calibrated white target. So once again, all of this information is available. We just have to stitch it together in the right order. For the measurement value emission color, it's 7 bits and then plus 2 more. So we got 9 bits. Emission color is the KTS can actually do multiple colors. It could do red, green, or blue. And so for this one, that's going to be a number 0, 1, or 2 for red, green, or blue. And then the last two at the end here, we've got our Boolean at the Q output. That's just the switching output of the sensor. So that's what you get without IO-Link, the 1 or 0. And then the quality of run alarm is another kind of a second switching output that'll tell you if you're getting poor printing in your process, if you're running out of ink maybe. But again, all this information is available. It's just up to us to stitch it together in an easy to use way. So I briefly mentioned if stitching that information together is easy for you. I'm a sensor guy. I've been working with sensors and troubleshooting sensors for 8 years. Stitching data together isn't too easy. I would much rather talk about why sunlight affects your sensor and what's going on there. But what's nice is we offer for every single one of our sensors, we offer add-on instructions or function blocks that help format that data in an easy to read way. So this page here is showing the top right is an expanded view of what you can get to. So within RS Logics, these are looking at controller tags here. You can actually see a number that says process data, measurement value, and see a number that's between 0 and 999, like you would see on the top of the sensor. And then we can see the emission color, 0, 1, or 2, and those correlate to red, green, and blue. So you can see that. And then the quality of run alarm and the Q output, right now both of those are 0s. They're not active. They can switch to 1s, and you can see that they're active. So we can get to the point where it's just as easy as you're used to seeing in your digital I/O, but now you have a lot of extra information. And the way that you do that is just by adding the function block. We've got a function block for process data and service data. We spend time on that in one of the videos, and I spent time in the last webinar, so I won't spend time on the differences between process and service data here. Beyond process data is the update cycle data. That's fast. Sensor's always spitting it out, and service data is upon request. So for the process data, we set up a copy function to pull in all the information that sensor's spitting out, put it into an array. We set up a basic little array. Oh, sorry, I went the wrong way. We set up a basic little array. We tell them how many bytes of data we're looking for, and then we use the parser, which is available for download on our website for any IO-Link sensor. And all we're going to do there is tell it what port to look at. Find the data, find the right port, and then output into our controller tags the information that actually means something to me. So that's what we're looking at here. And you can see we're actually looking at our controller tags and where that information comes out. Here's a quick look at our service data. We've got function blocks. Process data and service data have to be separate. You can't actually get both information at the same time. You'll see it. We'll just toggle between the two, but in your ladder logic or your programming, just make sure that you've got those separated. The common mistake that people run into. But the service data, essentially any kind of additional information that this contrast sensor can output is going to be available here. We'll go through. For this one, you got to set up 2 messages, and then again tell it the port to look for. But we'll go into it and we'll say, hey, I want you to pull this one, and this one, just these specific parts of service data. Again, this is where we need to work together. I can tell you what the sensor can output, but only you can tell me why that value is important. So we need to work together about what's available and how it can actually help improve your machine process. This one, I'll just show an example of temperature, because I think that one, in many cases, is an easy way to show additional information coming and how we can maybe start to use it. The process data here, the service data here, you can see we're pulling vendor name, product name, that's the model code. We've got the actual 7-digit part numbers available. All kinds of different things are available in there. But really, what we're going to look at is something that can help me improve my process. Temperature is one. Supply voltage is another. Again, we could talk about this. Just start to be thinking on your own. If the sensor could give me that and I didn't have to slap on another sensor on the machine, maybe that's some real value that we can see. Here, all we would do is using our function block is we would request our function block for output, or sorry, our data for output temperature. And when that comes in, we'll go back to our data map here at the bottom. You'll see index 153 is for temperature, and the format of that data comes in degrees C. You see 48, internal temperature of the KTS sensor as it's running there is 48 degrees C. So pretty simple once you kind of see the steps going through. And again, the point of this kind of webinar was just to show that SIC's got the resources available to support you in this. If you want to start playing with an IO-Link master, we can sample and we can get them out to you. But really, it's easier than you might think to get that data all the way over and set up and actually usable in your machine. And that switching output, the Q, is still available. So what you're used to today, you don't lose. You still have that. And so it's really not quite as difficult as people might think getting into the nuts and bolts of IO-Link. The other thing I want to say is function blocks are really valuable if you're not in a PLC every single day and you've got to solve sensor problems like the rest of us. The function blocks, we actually have something we call a function block factory that we're going to be launching really soon. So if you have a device that has an IODD file but it doesn't have the function block available, we can actually build that out for any of our sensors. And if you have competitors involved, we'll first try to cross it to our sensor, but then we can support you with competitor function blocks as well. So if that's at all interesting to you, please reach out to myself or your SIC representative and we can get that over as well. I think my last slide here is just links to those videos. If you just search SIC IO-link, you'll find those videos. But if you need it, you feel free to reach out to us. I can put them in the chat if you want as well. But that's kind of the quick overview of how you get into the nuts and bolts of actual IO-Link. So without anything else, I'll throw it over to some questions.
Thank you, Jake. Wait for questions to come in. I want to activate a fun poll for all those Tiger King fans. Hope you enjoy it. But Jake, the first question we will begin with is, will the IO-Link data look the same in PLC platforms other than RS Logix?
Yeah, so that's a good question. If you're using something, you're using TIA Portal or you're using EtherCAT. If you're using other PLCs, the data looks pretty similar. It still shows up in something like the controller tags. TIA Portal, I know it looks very, very similar to RS Logix, and so we can see that data there. Each of them are going to be a little bit different in the way that you set up your add-on instructions. But again, we have support for how to get those add-on instructions added. So if you do need some help, we can help you out with that. But the data in the end is going to come down with measurement value, and you're going to see a decimal.
Great. The next question is, can new IO-Link sensors be added to existing systems without having to restart the IO-Link master?
That's a good question. So I'll maybe qualify it with a couple of different ways. If you're adding an IO-Link sensor that was the same part number, same model number that was already configured, you can do that. We call it hot swap would be the setup. And that's a function that normally is set up in the IO-Link master. But you could set up some code to do it in your PLC where it would look for the specific model code and then look for a parameter and say, hey, if I see this model code and the parameter isn't correct, send it this set of parameters. You can do that, but the IO-Link master actually does it live. But we call it hot swap. That's another one. I did put together a video of that showing how you can unplug a sensor, change the parameters, plug it into a master, and those parameters revert right back to what was saved in the master. So that, I think, is what the question is. On the other side of that question, if the question was more, hey, I have a standard IO sensor and I want to change to an IO-Link sensor, that's a little bit more complicated. The nice thing about IO-Link is if you have an IO-Link sensor and you want to plug it into an old system that doesn't have an IO-Link master, it actually still will function. So the sensors are looking, it sends out a request, and if it gets a response, then it starts shooting IO-Link data. If it doesn't get that response, then it just operates as a standard digital I/O sensor. So today, if you had a sensor that wasn't IO-Link, you wanted to replace it with an IO-Link one, you put it on the system, be able to function, and then when you implemented a master, then it would start spitting that IO-Link data. So hopefully I answered that question, and if I didn't, please send me an email and I'll get to it.
Awesome. Question comes from Vivian. She asks, What are the differences between the IO-Link master and SIG 100 master? When do you choose one or the other?
Yeah, it's a great question. So the SIG 100 shouldn't be called a master. It should be called a hub or a slave module. SIG 100 is just digital I/O. So that's the difference between a slave and a master, or a master and a hub, is the master takes IO-Link data and puts it onto a field bus, Ethernet IP, Profinet, EtherCAT, whatever it is. The hub module, or the slave module, that takes digital I/O and converts it to IO-Link, okay? So they're just different converters. You'd kind of set them up above each other in kind of a pyramid, an automation pyramid, where it would go slave module, master, and then PLC, and cloud up above. I always will ask the question, you have a sensor, do you want IO-Link data out of that sensor? If you do, then you have to go to a master. But if you don't, if you just want the digital switching yes, no, then you go into the hub module.
Awesome. Another question is how do you go about changing set points? Is that explained in the YouTube videos?
So this YouTube video does not explain changing set points, but we can share instructions for how to do that. Essentially, there's 4 fields that you have to adjust. So you'll adjust, what am I looking for? Normally there's multiple switching outputs. You have to say I'm looking at Q1, and then what mode do you want it to be in? Because most of the sensors have modes, window modes or distance modes, those kinds of things. And then what do you want that set point to be? And then you execute it. So if you do it in a PLC, it's basically 4 steps that you go through. But then masters can save parameters for you as well.
Awesome. We are running out of time, but I'll ask you, Jake, one more question. Can the IO-Link help diagnose cable issues? This customer says, sometimes I have issues with bad cables because intermittent issues, such as losing a signal. Can IO-Link help diagnose those issues, and how?
Yeah, so it's going to be an error code that just says chain link error or connection issue. But you will get an error code, and you'll get what channel it's coming on. So if you're having an issue on a cable between a master and a sensor, it'll be coming out of a specific port, and you'll get an error on that port. There's a number of different errors that you can get through IO-Link. So that I would say yes in most cases.
Awesome. I do see more questions come in, but I'll have Jake reach out to you following today's presentation. And I want to thank you again to our listeners for listening.